There was a time when humanity looked at the night sky and believed we understood its size. We saw thousands of stars. We saw the glowing river of light stretching across the darkness. And we believed that was the universe. But the universe had been hiding something from us. A truth so enormous that when humanity finally discovered it, our entire understanding of existence had to be rewritten. The stars we could see were not the whole story. The Milky Way was not the universe. It was only one island floating inside an ocean so vast that our minds struggled to comprehend it. And tonight, I want to take you on a journey through the greatest question humanity has ever asked. How many galaxies are there in the universe? At first, this sounds like a simple question. A question that should have a simple answer. Just like counting the planets around our sun. Just like counting the moons orbiting Jupiter. But the universe does not reveal its secrets so easily. Because every galaxy we count is only a galaxy whose light has managed to reach us. There may be countless others hidden beyond our vision, too distant, too faint, too ancient. Their light may still be traveling across the darkness, carrying information from a universe that existed billions of years ago. When I developed my ideas about space and time, I learned something important. Reality is not always what appears before our eyes. The universe does not adjust itself to human understanding. We must adjust ourselves to the universe. And the story of galaxies is one of the greatest examples of this lesson. For thousands of years, humanity believed the Milky Way was everything. A giant cosmic structure containing every star that existed. When ancient civilizations looked upward, they saw stories written among the stars. Some imagined a river across the heavens. Others imagined a path of light, but nobody knew what that glowing band truly was.
They were looking at something extraordinary, not a cloud, not a simple decoration in the sky. They were looking at hundreds of billions of stars belonging to a gigantic galaxy, a galaxy we call home, the Milky Way. Every star visible to your eyes on a dark night belongs to this enormous structure. Every constellation, every familiar point of light, every planet reflecting the sun's energy.
All of them exist inside this single cosmic island. But imagine the first moment when humanity discovered that this island was not alone. Imagine realizing that what we called the universe was only one small part of something much greater. That moment would change everything. And the first clue came from one of humanity's greatest inventions, the telescope. When Galileo first pointed his telescope toward the sky, he did not simply improve human vision. He changed human history. He looked toward the mysterious glowing band called the Milky Way, and something impossible happened. The strange light dissolved. What appeared to be a single cloudy structure became thousands upon thousands of individual stars. The Milky Way was not a mysterious glow. It was a vast collection of distant suns. Galileo had opened a door, and behind that door was a universe much deeper than anyone imagined. But the greatest surprise was still waiting. As telescopes improved, astronomers began discovering strange objects scattered throughout the sky. They were not sharp points of light like stars. They appeared as small, blurry patches. Astronomers called them nebulae, clouds. Some of these objects truly were clouds of gas inside our galaxy, but others were different. Some had beautiful spiral shapes, structures that looked like giant cosmic whirlpools frozen in space, and humanity faced a terrifying question. What were these mysterious spirals? Were they small objects inside our own Milky Way, or were they something far more incredible? Could they be entire galaxies themselves? Separate universes filled with billions of stars? The idea seemed almost impossible. At the time, the Milky Way was believed to be the entire creation. The thought that there could be other galaxies beyond it was almost too large for human imagination. But science is not controlled by what feels comfortable. It is controlled by evidence. And eventually, the universe revealed the answer. The discovery came through a special kind of star, a star that changes brightness in a predictable rhythm, a cosmic clock. These stars are called Cepheid variables. Their importance was revolutionary because their brightness tells us their true distance. They are like natural measuring tools placed throughout the universe. If we know how bright something truly is, and we measure how bright it appears from Earth, we can calculate how far away it must be. And one astronomer used this method to study one of the most famous objects in the sky. Andromeda, that faint blurry patch visible under the right conditions. To the human eye, it appears almost insignificant, a small mark of light, but hidden inside that tiny glow was a revelation. Andromeda was not inside the Milky Way. It was far beyond it, a separate galaxy, an entire collection of stars millions of light years away. In that moment, humanity's universe expanded. The Milky Way went from being everything to becoming just one galaxy among countless others. The darkness between the stars was not empty. It was filled with unimaginable worlds. And once we understood this, a new question appeared. If there is another galaxy, how many galaxies are there? Hundreds, thousands, millions, or a number so large that the human mind cannot truly visualize it? The discovery of other galaxies changed our understanding of space forever. But the universe was not finished surprising us. Because once we accepted that galaxies existed beyond the Milky Way, another mystery appeared. How does the universe itself behave? Are galaxies scattered through a fixed eternal space, or is space itself changing? When I developed the theory of relativity, one of the greatest ideas that emerged was that space and time are not separate, rigid stages where events simply happen. They are connected. They form a single structure, space-time. And this structure is not motionless. It can stretch, it can bend, it can evolve. Years after my work on relativity, astronomers made one of the most astonishing discoveries in human history. They looked at distant galaxies and noticed something strange. Almost every galaxy appeared to be moving away from us. At first, this seemed impossible. Perhaps Earth was somehow located at the center of a cosmic explosion, but the truth was far more beautiful. The galaxies were not simply flying away through space. Space itself was expanding. Imagine placing small marks on the surface of a balloon. As the balloon inflates, every mark moves away from every other mark, not because the marks are traveling across the surface, but because the surface itself is stretching. The universe behaves in a similar way. The space between galaxies grows larger, carrying galaxies along with it. This discovery transformed our understanding of the cosmos. The universe was not a static picture. It was a living story, a story that began billions of years ago. And this expanding universe gave astronomers something extraordinary. A way to measure the past, because light does not travel instantly. When we look at distant objects, we are not seeing them as they are now. We are seeing them as they were when their light began its journey. A galaxy 1 billion light years away is not shown to us in the present. We are seeing a message from 1 billion years ago. The universe is filled with ancient photographs. Every telescope is a time machine. The farther we look, the further back into history we travel. And this idea became essential when humanity attempted to answer the impossible question: how many galaxies exist? To count galaxies, we first needed to know how far away they were. Astronomers created what is called the cosmic distance ladder, a series of methods that allow us to measure increasing distances throughout the universe. The first steps involve nearby stars. By observing how stars appear to shift slightly as Earth moves around the sun, astronomers can calculate their distance. For objects farther away, they use special stars like Cepheid variables. And for even greater distances, they use powerful cosmic events, such as certain supernova explosions. These explosions are so bright that they can be seen across enormous distances. Each method builds upon the previous one, step by step, measurement by measurement. humanity began climbing outward from our small corner of space toward the edge of the observable universe. But even with better measurements, we still faced a problem. The universe was hiding its galaxies from us. The galaxies we could see were only the brightest ones, the easiest ones to detect. The universe contains countless objects too faint for early telescopes. So astronomers needed a new way to search, and that search required one of the boldest experiments in the history of astronomy: a telescope in space, the Hubble Space Telescope. When Hubble was launched, astronomers had already discovered thousands of galaxies, but nobody knew how many more were waiting beyond our vision. Then came a strange idea. Instead of pointing the telescope toward a beautiful region filled with stars, they pointed it toward almost nothing. A tiny, dark patch of sky. A place that appeared completely empty. It was a risky decision. A telescope this valuable could have been used to study bright galaxies, planets, and famous cosmic objects. Instead, scientists chose darkness. They asked a simple but profound question. What if the emptiness itself is hiding something? The telescope stared at this tiny region for days, collecting the faintest particles of light, waiting, searching, looking deeper than humanity had ever looked before. And then the image arrived. What appeared to be empty space was not empty at all. It was overflowing. Inside that tiny patch of darkness were thousands of galaxies. Not thousands of stars, thousands of galaxies, each one containing millions, billions, or even trillions of stars. The darkness was not a void. The darkness was full. Humanity had simply not looked deeply enough. This image became known as the Hubble Deep Field, and it changed astronomy forever. Because scientists realized something incredible. If one tiny piece of sky contained thousands of galaxies, then the entire universe must contain an unimaginable number. The next question was no longer whether galaxies were everywhere. The evidence had answered that. The question became, exactly how many are there? And the answer would become far larger than anyone expected. The Hubble Deep Field revealed something humanity had never truly understood before. The universe was not just larger than we imagined. It was filled with structures beyond imagination. Every small point of light represented a story, a galaxy with its own stars, its own history, its own billions of years of evolution. And perhaps somewhere inside those distant galaxies, planets were forming, oceans were appearing, and someone else might have been looking back at the same universe asking the same question: how many galaxies exist? But the deeper we looked, the stranger the answer became. The first estimates suggested that the observable universe contained hundreds of billions of galaxies, a number already almost impossible to understand. But later observations showed that even this estimate was too small. Many galaxies were too faint, too small, too distant, hidden in the darkness. Astronomers began using more advanced telescopes and more powerful computer models to study these invisible populations. And they discovered something remarkable. For every large, bright galaxy, like the Milky Way, there may be countless smaller galaxies that are almost impossible to see. Tiny cosmic islands containing thousands or millions of stars. They may look insignificant compared with giant spiral galaxies, but they played a crucial role in building the universe we see today. The universe is not dominated only by magnificent giants. It is also shaped by countless smaller worlds. A cosmic civilization is built not only by the largest structures, but by the accumulation of billions of smaller ones. Today, scientists estimate that the observable universe may contain around 2 trillion galaxies. 2 trillion, a number so large that human intuition almost fails. To understand this scale, imagine trying to count them. If you counted one galaxy every second without stopping for a single moment, you would need more than 60,000 years. And remember, that is only the observable universe. The part of the universe whose light has had enough time to reach Earth. Beyond this horizon, there may be more galaxies, perhaps many more, but their light has not arrived yet. The universe may be far larger than the part we can observe. And this raises one of the deepest questions in cosmology. What does the universe look like beyond our cosmic horizon? The answer remains unknown. Because the speed of light creates a natural limit. Light is the fastest messenger in the universe, but even light needs time. A signal from a distant galaxy may travel for billions of years before reaching us. If a galaxy is far enough away, its light may never reach Earth, not because the galaxy disappeared, not because the light stopped, but because the expansion of the universe stretches space faster than that light can overcome. There are places in the universe that exist forever beyond our ability to see. Reality is larger than observation, and this is one of the most humbling lessons of science. The universe does not end where our vision ends. Our knowledge has boundaries the cosmos does not. But there is another mystery hidden inside the question of galaxies. If galaxies are everywhere, how did they form? Why are some spiral-shaped like the Milky Way? Why are some giant elliptical structures filled with older stars? Why do galaxies gather together into enormous clusters? The answer takes us back to the earliest moments of cosmic history. The universe began in a state that was incredibly smooth, but not perfectly smooth. Tiny differences existed, small variations in density, almost invisible changes, but gravity noticed them. Gravity has patience. A region with slightly more matter pulled in more material. That region became even denser. Eventually, these regions became the foundations of galaxies. Over billions of years, gravity transformed tiny differences into enormous structures. A small beginning created a cosmic architecture. Galaxies did not appear randomly. They formed along a giant invisible structure called the cosmic web. Imagine the largest network ever created, a web stretching across the universe. Long filaments of matter connecting enormous empty regions called voids. Galaxies are not scattered like random lights. They gather along these invisible highways. Where matter collects, galaxies form. Where matter is missing, darkness dominates. The universe has a structure, a design created not by intention, but by the natural laws written into reality. And inside this structure, galaxies continue to change. They are not permanent objects, they are living cosmic systems. Stars are born, stars die, gas clouds collapse, supernova explosions scatter new elements, galaxies collide, and through these collisions, new galaxies can be created. Our own Milky Way is not traveling alone. It is part of a group of galaxies called the Local Group. And one day, billions of years in the future, the Milky Way will meet its enormous neighbor, the Andromeda Galaxy. Two galaxies, two cosmic cities, moving toward each other through space. The collision will not be like two solid objects crashing. A galaxy is mostly empty space. The individual stars are separated by enormous distances, but gravity will reshape both galaxies. Their spiral structures will be transformed. Their stars will be rearranged. A new galaxy will eventually emerge from this cosmic encounter. The universe is constantly rebuilding itself. Nothing remains exactly the same. Even galaxies, which appear eternal from our perspective, are temporary chapters in a much longer story. But there is one final mystery. If the universe contains trillions of galaxies, why do we see only a fraction of them? And what will happen to these galaxies in the distant future? Will the universe continue creating new structures forever? Or will there come a time when the last stars disappear and the galaxies fade into darkness? To answer that, we must travel far beyond the present and look toward the ultimate future of the universe. When we look into the future of galaxies, we are no longer looking at years, not centuries, not even millions of years. We are looking at timescales so enormous that the entire history of human civilization becomes almost invisible. The universe has existed for nearly 14 billion years. But compared with the future ahead, we are living in the earliest moments of cosmic history. Today, galaxies are active, stars are being born, gas clouds collapse, new worlds are forming. The universe is filled with light. But this will not last forever. The future of galaxies will be shaped by one of the greatest mysteries in modern physics: dark energy. When astronomers first discovered that the universe was expanding, many believed gravity would eventually slow that expansion. After all, gravity pulls matter together. It creates stars, it creates galaxies, it creates planets, so it seemed natural that gravity would eventually overcome expansion. But the universe had another surprise. The expansion was not slowing down, it was accelerating. Something was causing space itself to stretch faster and faster. Scientists gave this unknown phenomenon a name: dark energy. We still do not fully understand what dark energy is, but we know what effect it has. It is changing the future of every galaxy. As the universe expands, galaxies become separated by greater and greater distances. The space between them grows. Eventually, galaxies that are not gravitationally connected will move beyond each other's observable reach. Their light will become weaker. Their signals will disappear. Future civilizations, if they exist, may look into the sky and see a much emptier universe than we see today. They may not know that countless galaxies once existed beyond their horizon. They may believe their own galaxy is alone. Just as ancient humans once believed the Milky Way was the entire universe. The universe itself changes what can be known. But inside our own galaxy, the story will continue. The Milky Way will not disappear immediately. Stars will continue forming from the gas that remains. But slowly, the fuel will run out. New stars will become rarer. The brilliant lights that fill the night sky today will gradually fade. The universe will enter a quieter age, a time when the great cosmic factories of stars begin shutting down. The stars that remain will eventually reach the end of their lives. Massive stars will explode. Smaller stars like our sun will transform into white dwarfs. The universe will become darker, but even darkness has a story. The remnants of ancient stars will continue drifting through space. White dwarfs, neutron stars, black holes, the remains of billions of years of cosmic evolution. The galaxies themselves will still exist, but they will become collections of old, fading objects. And eventually, even the largest structures in the universe will face change. Galaxies will continue merging. Black holes at their centers may combine. Matter will become increasingly spread out. The universe will approach a state of incredible emptiness, a possibility scientists call the heat death of the universe. Not because the universe becomes extremely hot, but because it reaches a state where energy differences become too small to create significant change. A universe where stars no longer shine, where new structures rarely form, where cosmic activity slowly approaches silence. But before we imagine this distant future, we should return to the question that began our journey. How many galaxies are there? The answer is not simply a number. It is a story of discovery, a story of humanity realizing that every answer creates a deeper question. We began by believing the Milky Way was everything. Then we discovered other galaxies, then billions, then trillions, and perhaps beyond our observable universe even more. The universe has repeatedly challenged our sense of scale. Every time we thought we had reached the edge, we discovered another horizon. This is the true lesson of astronomy. It is not only about counting objects in space, it is about understanding our place within a reality far larger than ourselves. When I developed my theories, I often thought about the relationship between human knowledge and the universe. We are small creatures on a small planet. Yet somehow, through curiosity and imagination, we have discovered the structure of space. We have measured the age of the universe. We have calculated the existence of invisible objects. We have detected galaxies whose light began traveling before humanity existed. A photon can leave a distant galaxy billions of years ago, travel across the expanding universe, and finally enter a telescope built by human hands. That journey is extraordinary because when we observe the universe, we are not simply looking outward, we are looking backward. we are seeing history written in light. Every galaxy is a message from the past. Every star carries information about the conditions that created it. Every element inside your body was formed through ancient cosmic processes. The iron in your blood, the calcium in your bones, the atoms that make you who you are. They were created inside stars that lived and died billions of years ago. You are connected to the galaxies you observe. The universe did not simply create galaxies. It created the conditions for galaxies to create stars, stars to create planets, planets to create life, and life to look back and ask, what is this universe? That may be the most remarkable discovery of all. The universe became aware of itself through us. A tiny species on one small world discovered that it lives inside a cosmos containing trillions of galaxies. A cosmos so large that our minds struggle to imagine it. Yet we continue searching, we continue asking, we continue exploring, because the universe is not only something we exist inside, it is something we are part of. So when you look at the night sky and see a few points of light, remember what you are truly seeing. You are not looking at empty darkness. You are looking at ancient suns, distant galaxies, structures that have existed for billions of years. You are looking at a universe that has been expanding, evolving, and transforming since its beginning. And somewhere, far beyond what we can see, there may be galaxies whose light is still traveling toward us. Messages from places we have never discovered, waiting to reveal another chapter of the greatest story ever written. The universe is larger than our imagination. But perhaps the most beautiful mystery is not how many galaxies exist. It is that among all those galaxies, on one small planet, the universe created beings capable of asking the question, how many galaxies are there and why are we here to count them? What amazes you more? The unimaginable number of galaxies in the universe, or the fact that the universe created a way to understand itself through human curiosity? Subscribe for more documentaries exploring the deepest mysteries of space, time, and reality. And